Alright, so I want to show you the tool that I created, which is called Y plus Calculator. With this calculator you can pre-calculate, so before the simulation runs, you can estimate the size of the boundary layer right at the surface. Okay, so you have on your left section you have your input parameters. Now if you type in the values of the properties like velocity, length, and the density of air, and then the viscosity approximately of air, and then your Y plus target. Okay, now let me select the Y plus target of 100. So if I hit the calculate button, you will see your Reynolds number, your friction coefficient according to Schlichting, your wall shear stress that is calculated, and so and the friction velocity, your Y value, that is the corresponding value for a Y plus target of 100. So your cell height needs to be 1.85 millimeters. So your base mesh size you can grab from the background tab over here, and the boundary cell level is the value we have at the boundary layer. It's like 4 for the main body, and then your outermost layer relative thickness we've taken like a value of 0.3 over here. So the growth rate is 1.2, expansion rate, growth rate, and for the number of layers we did take like 3. And if I calculate, you will get the table like here, and down here you have your legend, and in the legend you can see the values over here. So your first layer will be the innermost layer, and then it will grow with layer number 2 and 3. You will have the sizes over here. Okay, the aspect ratio, and then the cumulative thickness, the total thickness of the boundary layer, and then the distance to the center of it, and then the Y plus value. So this is 106 approximately, the target value you have chosen over here. And then in this table you have like your level, your base mesh is 150, so you will have 150 over here, and then these are the refinement levels and the size of this. And at the surface you will have like 9.37 millimeters, and we said that we have 0.3 as factor, so the size of the outermost layer will be like 1/3 of this value. It's this value, and the growth rate will just dictate what the next layer after that is extruded will look like. So the value from this to the second layer will have a ratio of 1.2, and then it will go like this. You can of course take like 10 layers, and then you will have like different values over here. Like this is a log layer, in green you have the log layer, and the value of this 29.5 you will have like in the layer next to the surface, and you can use this tool like this. Let us go back to 3 layers, and the cell thickness is like 1.95 that these are the values that we have taken, and you can go to this and then enable the ruler and then measure. Like if you need to hover until the point snaps to the, what did I do? Sorry. Enable the ruler, zoom in, and then until you snap over here. This will be 2.8. This is this value, and then the next layer will be 2.3 something, 2.34, and then hereafter the innermost layer will be 1.95. It will be this value. So you can check approximately what kind of Y plus values you will have and choose your turbulence model accordingly.